Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, we're continuing our series of What is Fill-in-the-Blank Engineering, this time looking at plastics engineering.
Yeah, this one was, I think we both said this one was a little more difficult to research, and my guess is because it's pretty specialized.
Yeah, it's super specialized.
Like if you do plastics, you do plastics. Like if you're a mechanical, you can do everything because we're the best.
Fact.
Or if you're like a environmental, you can kind of do civil, you can kind of do this, but plastics is, if it's plastics, it's plastics.
Yeah, I think we've gone through all the biggies, like chemical, electrical, even aerospace, which is more specialized than, say, mechanical. And then civil, of course, all industrial. Did we do industrial engineering?
No, isn't your brother one?
He is, so we'll have to get on that one here next, maybe. But plastics is such a small subset of engineering that it really did become much more difficult.
So off the top of your head, James,
yeah,
what would you say plastics engineers do?
Well, the weird thing is that plastics engineering actually encompasses plastics material as well as plastics machinery. So the things that you would use for injection molding or whatever else. So plastic machinery is the general term for the types of machinery and devices that are used for plastics processing in the industry. The nature of plastic materials has a lot of unique challenges that comes with it. Based on the mechanical properties and the material properties and melting points and flexibilities and warpage and all of these different things. And that's why this is such a specialized field. And it's such a specialized field that Penn State actually kicks all of the plastics engineers out from the main campus. You don't go there. You actually go to a branch campus. And it isn't even offered at Penn State's main campus because it's just so specialized. So
did you go with me when we visited up there? Were we together?
I did not go with you on that trip, but
it was pretty cool. They're going to be on our list a little bit later when we talk about schools.
They are. So other properties that the plastics engineer have to address include things like durability, because some plastics are used indoors, some are used outdoors. Thermal properties, like your upper temperatures. And again, these properties vary greatly with the different types of plastics, and also the way that then they set, like the thermal properties will influence the amount of warpage or shrinkage going on with your parts. Electrical properties, barriers, and then also resistance to chemicals. So all things that you have to take into account when you're a plastics engineer.
So off the top of my head, I have a few bulleted items of what their primary responsibilities
in your head. You
into.
Bullet items? Is that how that works?
I do bullet them in my head.
Okay, good.
So they have to design plastics and or the injection mold process that actually fabricates it. So the molds themselves. They have to improve on existing mold machinery, and a lot of times, have an old design. Maybe you make something that makes the Frankfurter or the Happy Hot Dog Man, and you need to improve that piece of plastic machinery. That's kind of an inside joke that only a few people will get. They do research and development on new manufacturing processes because there's always things happening. That can improve the process.
Sure.
They analyze data and suggest improvements. They analyze the production quality of the machine line itself. So they do more than just. I just assumed all they did was sit there and melt plastic and put it in a mold. They actually do quite a bit more. They actually develop the finished part in a lot of cases. They'll design what that finished part looks like, and make sure that finished part has all of the necessary plastic-specific pieces of functionality. So it has to have the appropriate amount of draft so this thing can come out of a mold. So if you don't have the right draft, it won't come out. You have to make sure that it has all the gates and runners and inserts and bosses and all those different things to make sure it's structurally stable. Fun fact, I was working with our friend, Kristen, and I said, I have this part that I did for plastics, and I sent it to her, and she was like, "Yeah, this is terrible. There's no ribbing on the inside to make sure that." She's like, basically, if we would make this thing would just bend in half and crack. She's like, you need all this ribbing in here to give it some structural stability. You need to put bosses so that you can actually mount this to something. So
was this a piece that you were actually planning to manufacture, or was this CAD
it was
part?
a little demo piece we were working on together, and I clearly know nothing about what's necessary to make a plastic component.
So a little story for you, Luke, to
Shoot.
interrupt you, because that's what I like to do. Back in the day, I went to Autodesk University. This was years and years and years ago, and I was super bored. And at Autodesk University, you have the option to take tests to become certified in a product. And one of the Autodesk products is MoldFlow. And so for those of you who don't know, MoldFlow is a plastic injection molding software primarily, where it tells you how your plastic is going to get injected into your mold and what it's going to then look like. And so I took a test to become certified on it. And I believe, boy, it's been a long time, but I think I scored a 48% on the test.
Ooh.
It was not good. But in my defense, I had literally never opened the software up before, and I was just taking it because I was bored. So
Okay.
maybe it takes more than that.
So speaking of some of that analysis that MoldFlow does,
Yeah.
they analyze the quality and they correct flaws because, again, you talked about all these thermal properties. Like when you're pushing, molten lava or plastic into something, mostly lava, you want to cool it at a specific rate. You might need to keep it warmer so that it flows better. I mean, there's all kinds of crazy stuff that happens. Like I think I always thought that it was like two pieces of steel and then there's or whatever it is, and there's like the negative in the middle. But there's all kinds of cooling lines and runners, and
it's very intense.
Sometimes those lines actually heat the mold to keep it warm so it continues to flow. It's not always cooling. So they do a ton of work to make sure that like all those plastic pieces that pretty much everything in the world is made out of. Like I'm looking at my desk right now, my computer, my camera, my laptop. If there wasn't someone like Kristen making decisions, there'd be all kinds of like sink marks and like ugly, marks on the plastic based off of, it cooled too fast or, cooled, too slow, and it all looks beautiful because of someone that is a plastics engineer helping make some of those decisions.
If we were smart, we would have had one of our many plastics engineering colleagues join us for this.
Yeah, what do we need them for?
Well, nothing. We're smarter than them anyways.
Yeah.
But it was interesting that you mentioned sink marks. That's one of the big things. So warpage, shrinkage, and sink marks are among many of the problems that you have, along with weld lines. And I think it's called weld lines, right? So basically the weak points where the plastic fibers kind of orient themselves, which can cause a weak point.
So what happens with a weld line? You ready? I know what a weld line is.
Yeah, please.
It's whenever two separate flows of plastic come together and they meet, and where they meet, it just
it's
because
like a weak point.
Yeah, it's a weak point because they're not uniform with the way they meet, and you get a little line on there.
Yeah, I'm happy about this one because this isn't actually something I researched at all, so I feel a little good about myself. But the sink marks in particular are something that's interesting because there's a lot of stuff that you can do to make them not happen, but a lot of the times you never get rid of all of the sink marks, and they aren't necessarily bad for the structure itself of the part that you're creating, but they look really ugly. So there's actually a lot of research and software technology that goes into applying different colors to your parts. What happens if this is blue? What happens if this is blue with kind of like some sparkly glitter in it? What happens if it's red? And you use this rendering to understand if it masks those sink marks so that you can't see them in your finished product. And it's amazing the difference that the color, or even like the kind of like color texture provided to your part does for those sink marks and masking them. Okay, so before we go on, boy, that took a lot longer than I thought, but I love it.
It did.
How about we take a break for a word from our sponsor?
I have to assume that it's Dao Chemical or, maybe ExxonMobil.
Boy, I've been working with Dao Chemical in some capacity since I basically got out of college, but they did not sponsor me in this episode at all. In fact, we have no sponsor. But I know, I'm disappointed too. But we do have some shout-outs, which is great.
Let's hear him.
We have Alyssa C. She is a huge fan. Huge in very large letters.
Other kind of fan could we have?
Well, she's a very huge fan. But yes, you're right. She's a 12-year-old future engineer that says she's decided already that I'm going to be an engineer. I pretty much already am. So I like the confidence there. That's really
Very good
cool.
confidence. That's awesome.
Yeah, wants an episode on animation. And if I scrolled through my emails properly this morning, I believe she also wants an episode on how CD players work, or maybe even DVD players work, because her parents won't let her tear hers apart. So that it reminded me of you though, Luke, how you always talked about tearing apart radios and whatever else.
That's terrible parenting. Give your kids a screwdriver, unplug the thing, and let her have at it.
And now her parents won't let her listen to this. Thanks a lot,
Sorry.
Luke. Next shout out goes to Grant S. On his way to becoming a mechanical engineer, unlike one of
Nice.
those inferior engineering options. So good
Exactly.
choice, Grant. Yeah. Want some stickers, but didn't send me an address because engineers aren't that smart.
We're not necessarily detail people sometimes.
That is unscary but accurate. If you would like some stickers, if you'd like to give us some suggestions, if you want to tell us you're a huge fan, why don't you email us at unprofessionalengineering@gmail.com.
Or make sure you, or not or, but and.
There you go.
Make sure you subscribe, make sure you review, make sure you share. We love comments. Make sure you leave comments.
Oh, yeah.
That way we can not really act on them, but we can usually,
Feel
laugh
good about ourselves.
Yeah, feel good about ourselves, or if it's something that's negative, we can just ignore it. But we do love the comments. So
If it's something negative, I mean, I don't know if I've ever received a negative comment before.
ever in my life.
Okay, so let's take a step back, Luke, from what they actually do, and let's take a look at some of the best schools in America.
So I got a little bit of, I had a hard time finding.
I found a lot of lists. I had a lot of time finding consistency amongst those lists.
Exactly. There were a few that kind of were always at the top, but as soon as you got out of like the top 3 or 4, it was just like it was a free for all apparently.
Free for all.
And there's one website that usually lists all the pricing. I couldn't find it for this one.
Yeah, so usually I think I go to US News for my listings, and it has everything broken out so nicely. This time I couldn't find it for them.
I couldn't either.
Yeah. So here's my list, and let me see how yours matches up. How about that?
Shoot.
Okay, so number 1, I have the University of Massachusetts Lowell. Are they on your list?
That showed up as number 4 for me.
Okay, so I feel like this is, if we're
reasonable.
Yeah. So I know that we in our job work with that school a lot, so that's cool. Costs about $30,000, and I added another column here. It's the number of students there that go for this major. At the University of Massachusetts Lowell, there are 104 students.
That's
go
an
there.
awesome ratio.
Yeah. So that's 2% of the whole school, I guess, or something of that sort. The next one, number 2 on my list, is Pennsylvania State University, Penn State.
That matches
Erie.
up with my number 2.
All right, so the Barron College, $33,000 a year. Boy, school's gone up a lot since I went to Penn State. They have a whopping 39 students in plastics. Number
30. Or did you read that correctly? 39?
39. Yep.
Wow.
I know, crazy. Case Western Reserve came in at number 3 for me.
That was my number 1 on my list.
Okay, that's fair. I feel like
So
we're
we're
in the
close.
ballpark here. Yeah, $67,000, dude.
Yeah, Case Western is
67.
really expensive. One of my wife's friends went to Case Western, not for plastics, for something else, and it's a very it's like the Ivy League of Ohio, if there's such a thing.
Yeah, I was gonna say, isn't it in Cleveland or something?
It's
that
close.
area. I mean, go to Penn State then. My goodness, that is nuts. Number 4, I have the University of Akron. This is the first time we've ever mentioned the Zips in our.
They're number 9 on mine, but
Okay.
yeah, the Zips.
27,000, only to be matched by the 24 students.
You know what? You know what my guess is? So these universities that have like super low students, my guess is there's probably like 1 professor there or 2 professors that
Yeah.
are like just like geniuses in this field, and they literally probably run the entire program. Is my guess.
You probably get to be pretty tight with your fellow students and professors in this major. So I'm just going to rattle a few more off. Western Washington University, University of Massachusetts Amherst,
I saw that one.
Wisconsin Stout, and we actually have had a number of people write in that listen to our show that go to the University of Wisconsin Stout.
Okay,
Auburn University, which surprised
that's number
me.
7 for me.
University of Southern Mississippi, And
Don't have that one.
number 10 on my list, this one's crazy to me, is Lehigh University right here in Pennsylvania.
Lehigh was number 3 on mine.
I've seen it I saw it pretty high on some other lists, but this one again, over 68,000.
The only one you didn't mention was Stevens University of Technology.
I did not see Stevens. I did see a fun fact, though. Our friends at Ferris State University, who wrote in, I think, about the Formula SAE stuff, have a plastics program. And the cool thing is that the out-of-state, like for out-of-state people and Canadian students, they get in-state tuition rates. So for all of our Canadian friends out there, hop on your Zambonis and drive on into Ferris State University.
Is that what they drive? Zambonis.
I assume, right? They're fueled by maple syrup, too, so that's cool.
You know.
All right, moving on, Luke. What do you have next?
So I want to talk a little bit about the average pay. And again, I had a hard time finding some of this because, again, I think since this is a specialty engineering field of study, I couldn't find much of it. So
I'll be interested to hear your numbers, Luke, because I was thinking since it's such a specialized thing, they would be making bank. But I didn't necessarily find that.
No, so the average pay, so not median, so this is average. I have a couple of different numbers. So the average pay is $84,000, which isn't
That's around
terrible.
what I saw. Yeah,
I'll take $80K.
Yeah.
The average starting salary. So you graduate from one of these universities, and the average starting salary was 68, so it was a decent starting
I saw
salary.
it around 62, but yeah,
Okay.
that sounds in the ballpark.
But the problem is, whenever I was looking at this, there was this, it stays at 84 like forever.
Right?
Like you're like 4 years, 5 years, 10 years experience. And then eventually, like whenever you hover over, like I think I was on like Glassdoor.com or, one of those, as soon as you get like finally like 10 years and above, they start, breaking that $100,000 barrier, and they start to make some decent money. But the weird thing was, 10 plus years experience, you can start to break that $100,000 mark. But the weird thing was, I just did a quick search, plastics engineer on, I think I used Glassdoor. There were so many. That's why I don't know if I trust these numbers, these stats I was reading. There were so many that were like 120, 110,000. So I think it all depends on the company. I think it all depends on what industry you're getting into. Maybe if you're getting into research and development, you're going to make a little more money. If you're just working for like Pete and Joe's mold shop, you're probably not going to make a ton of money.
I don't know. Pete and Joe pay pretty well.
Pete and Joe do. But like if you're working for like HP or Dell or Lenovo and you're designing, the laptops and the cases and all that stuff, maybe you make a little bit better. So it was really all over the place for me.
Yeah.
So
speaking of companies that hire you, your Dells and Lenovos, here are a few companies that I saw that were big hirers, Luke. Nike.
You got it. You nailed it.
Nike is big into this. I would assume that makes sense to everyone. So I assume all the shoe places are. GM would be another company that's all about injection molding. The auto industry in general, all about plastics engineers, right? So the shapes of the body panels, different parts in the car, all sorts of stuff going on there. Of course, all of the tire companies, your Firestones and Michelins and Bridgestones, all of those. Luke, quick question. Were those stones like related, like Firestone and Bridgestone? Do you think one broke off of the other at some point?
I imagine there was a stone that moved from one to the other, I would guess.
That makes sense. And then, of course, the oil and gas companies as well. Of course, they have like petro engineers and whatnot, but they also have a lot of plastics going on. But you know who else is hiring, Luke? I was searching for this, and now it will be offered up to me endlessly until I search for something else. Phillips, right down the road from me here in Murraysville, is hiring. They're also working on making a whole bunch of respirators, so that's very nice. A little further down the road from us, Carnegie Robotics has been hot, and they're hiring some plastics. And then by my old house, Westinghouse in Churchill is also hiring some. So
Westinghouse is hiring?
Yeah, I didn't realize that either.
I didn't think they were doing too well, but that's good.
Yeah, good for them. So all interesting stuff. So before we move on with our next segment, how about we take a break for this week's Luke's Rant?
Yeah, so here's my rant. It's related to plastics and recycling. If you haven't listened to our recycling episode, make sure that you do that.
E-cycling, nonetheless.
E-cycling, and this is all about like all of these products that we use each and every day. Whether it's your phone or your laptop, or I was downstairs using my espresso machine this morning, and like 90% of it's made out of some kind of plastic. None of that stuff is recycled properly. And some of it is, the end user doing it. Like, I'm sure that, like, Kristen and all these, plastics engineers, they're thinking recycling in mind when they're making stuff. Like, this has to be able to be, ground up and melted down and reused. I'm sure they think that way. So this isn't necessarily an issue with, plastics engineers and what they do. This is like the consumers. And I'm kind of, guilty of this. I'll take things that I definitely should not throw in the regular garbage, that I should, definitely throw into the recycle. But the problem is, a lot of times you have things that are like a mix of metal and plastic, and do I take it apart? Do I not take it apart? And I think what most of us do is we just kind of throw it in the regular trash because we're not sure what to do. So this is more like a PSA, a public service announcement, to be a little more responsible in your recycling. Maybe take a little extra time and maybe take some things apart and throw them into the recycling bin. But the problem is, like, how do you recycle? So like a camera, like I have this really nice camera. Like, when this thing breaks or gets old, like, what do I do with it? Do I put it in the garbage? Like, who's going to take this camera and take it apart?
I think you can take them to electronics stores and they'll do some recycling for you on certain products.
Or they put it in their regular garbage.
Well, I was going to say that's what they probably do. I like your PSA there, Luke.
So it's
that
a
was
PSA.
Very nice. Yeah.
Recycle, people.
Recycle. Made me think of a few things. One, if you want to learn how to recycle batteries properly, listen to our episode all about batteries. It involves putting them into a bag that people won't look into and throwing them into your garbage.
Yes.
Also,
no, I don't do that.
No, never. I think that we maybe should do an episode on recycling so that we can, as opposed to e-cycling, so that we can finally crack the mystery of why I'm allowed to recycle plastics with a certain number, but not plastics of another number. And why did my recycling company decide that I can no longer recycle glass? Because these things all annoy me, and they all make me recycle less. So I hate you, recycling company. There.
Wow.
I know, that was a little harsh. Okay, so I'm all about the Utes, and I want to guide them and let them know that what they would be in for plastics engineering.
So we're going to talk about classwork.
Yeah, I just wanted to talk about some of the classes. And so each time we do one of these engineerings, I tell you that you're going to have the same general classes like a chemistry or bio class. You're going to have all of the physicses. You're going to have 9 million calculus classes. You're going to have all of the general education classes. But when you get into the core of things here, you're going to have a lot of plastic-specific classes, and you're going to have a lot of electives for your major as well. So some of these would look like plastic processing theory. That sounds really interesting.
Very interesting.
Polymer blends, porous polymers, learning about new plastic materials, lean plastic manufacturing. I think that one's kind of interesting, actually. Adhesives and adhesion, coating sciences and technology, rubber technology falls into this, biomaterials, advanced mold design. So this would have a lot to do with what you were talking about, Luke, with how your part was terrible and how the mold would be designed to make it work. These two sound just terrible. Polymer nanocomposites and nanoscale transport phenomena for manufacturing nano devices.
I would fail the class because I couldn't write the title.
Like, what does that even mean?
Yeah, this sounds, you know what, I was thinking this sounded interesting, but the more you're describing what you'd have to do, this sounds terrible.
Some of my electives for mechanical engineering, I took an acoustics class, and it was just awful. So I bet there's some real stinkers here, too. But once you graduate, why don't you join the Society of Plastics Engineers? And a kind of interesting thing about that, the Society of Plastic Engineers, SPE, is an international organization dedicated to the advancement of knowledge and education for all plastics professionals. And it was founded way back in 1942. I did not expect it to be that old. I figured plastics was a much newer thing.
And there's more than 20,000 professionals just in the United States alone, and they're in over 70 countries.
70?
70.
Huh, that's pretty impressive.
That is impressive.
Cool. All right, so what do you have next, Luke?
So I have companies that actually produce plastic. So this wasn't like the design companies. These are the companies that probably make like some of the raw material that like a mold shop would take and
like
make that with.
the people that I mentioned would be the ones that hire plastics engineers to do the manufacturing of their parts and ensuring that their molds are solid and whatnot. And you're talking about the actual plastic production then.
Yeah, and you could work at one of these joints because a lot of the plastics engineering involves the formula of the plastic. Like you mentioned composites, and like when most of us think of plastic, it's just like it's a single uniform material that you melt and that's all it does. And while that does happen, I would say in most cases plastics are some type of composite material. So whether it's a composite material where they're maybe throwing fibers in it to strengthen it, maybe they're mixing two different types of plastic. Maybe they're layering the plastic, so you might have different layers of material. So you might have plastic and then some carbon fiber and then another material. So there's all kinds of ways to make things out of plastic either stronger, perform better, resist chemicals, and all of that goes into like the formula of the bits and pieces. So when you think of what this plastic looks like, it looks like when it shows up at Tim and Bob's machine shop, and they're going to melt this down.
Joe and Pete's.
When Joe and Pete's machine shop, and they're going to melt this down and throw it into a mold to make happy hot dog men. What?
Every time.
Sorry. So it looks basically like rice pellets almost. So it's typically pelletized. It's really small. It looks like cat litter kind of. It might have different colors. It might have different textures.
Hopefully it smells better than cat litter.
Hopefully it does. So these companies actually produce that material. So the first one I mentioned was Dao Chemical, who I think a lot of us have heard of. They also do a lot of other engineering, but they do create the raw materials. Han Wool Corporation, and these are in order of like biggest companies.
I've never even heard of them.
I never have either.
Wool?
Another one is called Lionsdale Basile. Never heard of it. Another one, Inhel and Tech GmbH. So that's obviously in Germany.
German, yeah.
ExxonMobil. That's the only one I've ever heard of.
Yeah.
Matsuma Technologies. They're out of India. And then the only other one that anybody would recognize is BASF. And BASF is the people that used to make the cassettes back in the day that I remember.
Who was those? Yeah, I remember those. Who was the third one you mentioned?
The third one was Lionsdale Basile.
That's the one. Have you ever been to Del Taco?
No, but I'm intrigued.
I've never been to Del Taco either. I've been told that it's like even worse than Taco Bell, so maybe that means it's better than Taco Bell. If you're into that sort of thing,
okay,
I don't know.
Okay.
So I've never been to Del Taco, but anyways, that has nothing to do with plastics engineering.
It doesn't.
Do you have anything else that you wanted to cover?
So I wanted to ask you,
sure,
if you had it all to do over again. So we've done a couple of these, and I'm going to keep asking you this as we do more and more of these. If you had it to do over again, would you change and be a plastics engineer or a civil or an aerospace or
I have
of
to
all the
stick
things
with
we've
engineering.
Done? You have to stay within engineering. You can't say you want to go be a professional hand model or something like that. It has to be
like George Costanza.
Exactly, like George Costanza.
If I were to change, I would become a civil engineer. No, I wouldn't.
Oh,
that was a funny joke. You see,
that was very funny.
I would probably, let's say, I would probably stick with mechanical. But if I were to change, I would probably go with aerospace.
Okay.
How about yourself? Which one do you like?
We haven't done it yet, but I think industrial is interesting.
Okay.
I might be totally wrong because
I don't think it's interesting.
I think when we do our industrial engineering episode here in the coming weeks, we'll see how it goes. But I think industrial because although computer hardware was pretty interesting to me as well.
Yeah, that's a good one. The programming that I would have to get through in school, just ugh.
Yeah.
Though they pay well. Industrials like do a whole lot of time studies and
Okay.
breakage and stuff. So maybe that would be interesting. But I think I would go aerospace and
Okay.
then try to get a job at NASA.
Sounds
'Cause why
good.
not? Cool. I like that question, Luke. If any of you would like to let us know what kind of engineering you would like to get into, if you want to tell us that we're doing a great job, a terrible job, an average job, if you just want to send in and say hi, all those things, why don't you email us at unprofessionalengineering@gmail.com. And until next time.
See it.